All right, thanks.
Thanks, guys.
All right, so I'm Liz Tyhas. I am a senior mechanical engineering major, and I'm also a business and entrepreneurship minor. So that's how I got involved in working with a 3D printer through the entrepreneurship minor that I took with Will.
Mm-hmm. And I'm Will Landis, and I'm a senior computer engineer, and I'm in the entrepreneurship minor as well, and I'm also in the computer science minor. So I kind of learned SolidWorks on my own, mainly for the entrepreneurship minor, and then I've done some other projects with SolidWorks since then.
Yeah. So we're going to start off. I want to show you the difference between the Makerbot that's right here and also the object printer. So I'm going to hand out some examples of things that we've done, and I'll just have you guys move them along. These ones go together because the one that's white and black is from the Makerbot, and the one that's completely white is from the object, which is in CR 105. And then you guys can just pass these things along. There's chains and all that. I just want you guys to get an idea of what it feels like when it comes out of the object and the Makerbot printer. So let's get started. So does everybody have a computer? I see some people who don't. If you don't have one with you, I'm just going to have you look on with the person next to you. And we're going to go through a whole agenda, and you'll get the sense, hopefully, of what our goals are for the day. All right, so this is a little bit of what I have designed in my history of 3D printing. You can see we actually had an ornament for the entrepreneurship minor. We had an ornament competition. Well, it was an ornament. It was just a 3D printed business proposition. And we actually both created, he won, but it's fine. You'll see his creation. But you can see that this is like the Villanova Bee 2014 ornament, the love. And then actually this summer, I worked for the Villanova Summer Incubator Program, funded by Harris Foundation. And I built a guitar pedal case that fits around the Raspberry Pi, which is a type of mini computer that I'm sure if you're an engineer, you'll get the chance to know what it is and work with it. And that basically fits perfectly around it, so it can act like and look like a guitar pedal.
These are some of the things that I've done. Down on the far end, you can see that's the Villanova Church, and that's the kind of the driving force to the project that I won last year. There's a little hole in the back of it, and then I glued a magnet in it, so it was a magnet that you could put on your fridge or anything. That took a long time, and I learned SolidWorks completely by making that thing. That was the first thing I ever made in SolidWorks. It took me hours upon hours, and that's kind of how I learned how to do things. The second one is a different church that I made. It's a church back home, and then this is a phone case that I was working on last year just for designing, random things.
All right, so we want to make sure that this workshop has goals. So what we want you to leave here with is to understand basic SolidWorks functions. We're going to go through a tutorial in order to do that, and you're going to follow along, and hopefully we'll get you more familiar with the functions. Also, to know how to save, format, send, and print a SolidWorks file that will either go to the Makerbot or it will go to the object printer. Also, becoming aware of available resources. We're going to have you, or suggest to you, to sign up for Thingiverse, which is something run by Makerbot, where you can actually explore, share, and look at different 3D objects that have already been created on 3D printers. And it's a really exciting area to be able to adventure into. And then leave with the ability to create. I'm actually, spoiler alert, I'm going to have it be like a little competition that once this is done and over and you guys have gotten an idea of it, I'm going to pick, I want you guys to send me just something that you created, something creative that you want to make. It's unique, it's original. And then I'm going to have you send it to me. I'm going to give you my email. I'm going to pick two designs that I'm going to print on the object printer for free. So that's just to get your wheels turning and also to get you excited about learning about this. All right, this is the agenda, and you can see we're just going to do an introduction, tutorial, discuss the process of getting ready to file it, and also the uses and resources. All right, so first I'm going to do a show of hands. Who already has it downloaded? Okay, who doesn't have it downloaded? Okay, so what I'm going to have those who don't have it downloaded already, you can use the V Desktop. So this V Desktop is essentially what you work through. That is via Villanova, and you can use this right now But if not, you can download it later, and I will send you, I'm going to ask for your guys' emails afterwards, and I can send this to you, and you can download it, or you can even update it if you want. All right, so, yes?
Does the EGR software portal, the file that it has, does that work for Mac and
Yeah, I think so, because it's going to be on Windows, but it will function.
I downloaded it, but I'm not sure if it will work.
Did you use the V Desktop?
I am using the V desktop.
Oh, okay.
But, I also have downloaded the other zip file from EGR portal.
Oh, okay, so you're asking, yeah.
I'm not sure if the zip file would work.
Yeah, I'm not sure, but I know that you'll be able to get it for free. We can work with you on that. But there's definitely, because it was already installed in our computers because we're engineers, so we aren't as well versed with Mac, but I'm sure that you'll be able to get it done.
Yeah.
All right, so this is what we're gonna start off with, and we're gonna have Will freehand a birdhouse, and we want you guys to follow along just to get a sense of what it's like to work with and become familiar with. And then we're gonna go through a short tutorial where I'll be able to send it to you, and you'll be able to follow along afterwards, after the workshop. So.
Okay. So how many people here have never used SolidWorks? Okay, good. So this is the best way to learn, is just going through and experimenting. It helps to have a little bit of guidance, something to push you along, so that's kind of what I'm going to give you now. Just some quick guidelines. We're going to build something very simple, and we're going to do it in a couple minutes. And that's going to be kind of your foundation for working. So we're going to build a birdhouse. So the first thing you want to do is create a new project, or a new what we call part. So you click new, and then you go to part. And the other pieces, I've never worked with the drawing, but assembly. Assembly is when you want to put two parts together. So that's something that we can discuss on another day if you're interested. So we're going to create a new part.
And let us know if you're getting behind, just raise your hand, and we can slow down.
Yeah, I'm going to try and take it nice and slow so you can follow along. But yeah, we'll be around if you need help. Okay. So you're going to start here with just a blank screen. And I always double click to get back to like the basics. So you're going to want to double click just any time to get through something. So the first thing we're going to do is we are going to sketch a rectangle. So you go up here to sketch, and then you click rectangle. So these are all the different pieces that you can kind of freehand sketch, which would be one-dimensional or two-dimensional. So every time you sketch something, you have to select a plane. So you can pick any one of these. I'm just going to select the front plane. And then I'm just going to click and drag and draw myself a rectangle. The next thing I'm going to use is the Smart Dimension tool. Smart Dimension allows you to set the dimensions of any line. I think right now I'm working in millimeters, and you can type in the dimension right here. I believe if I use inches, it'll just default it back to, it'll take my inches and convert it. So I'm just going to make my birdhouse 3 inches right here. And then I'm going to make it 5 inches on top. Okay. So next, we want to make this 3 dimensions. So we want to go to features, and we want to do an Extruded Boss. So these are all the different features that you can use kind of in 3 dimensions. So Extruded Boss, what that does is it brings out the 2 dimensions into 3 dimensions. So we're going to set that to be 1/2 inch thick. And then you just click OK, and there it builds it. And you can always double click off. So all right, there is your first plane of the birdhouse. Is everybody following along?
Is it?
Anybody having?
It looks like it's not square. Or no, it is. Oh, okay.
All right. You can use your arrow keys like I am. If you have a mouse, it's a lot easier. You can click and drag to kind of move your piece around. But I'm just using arrow keys right now. These tools at the top, you can use these tools to kind of zoom in. This one on the far left will zoom to fit. This one allows you to zoom into an area, so I could just take it and zoom right into the corner. The magnifying glass takes you back to the previous view. Okay, so now we're going to build the walls of our burr house. I'm envisioning this right now as the base, even though I built it on the front plane. You can kind of look at it from any perspective that you want. So I'm just going to go back to Sketch, and I'm going to select the Line tool. And now the first thing you have to do every time you do a sketch here is select the plane that you want to sketch on. So if you look around, I could sketch on this top plane, or I could sketch on any of these side planes as well. So I'm going to sketch on the top plane. And then you click the top plane. Now I'm going to draw what would be my walls. So you click, I'm going to click inside, and then I'm going to drag to the other side. You'll notice that the line should kind of run parallel, if it'll lock parallel to whatever you're on the edge of, or whatever you're close to. So I'm just going to click. I'm just going to draw all these lines, basically a rectangle as is, and you can kind of see when I bring this line up, it'll line up, and you'll get kind of a cross section right there, so it'll be tangent with another corner. The orange dot means that it's going to be tangent and collinear, or I guess it's collinear, co-pointal, whatever, with that point. So now what I want to do is I want to double click off that. In fact, I don't even think those go together.
Yeah, no.
So you want to make sure your box there is completely filled, lines through. So I'm just going to make sure that that's done right. Okay, so now I'm going to go back and use the Smart Dimension tool. So you can click on a line and you can Smart Dimension it. So I want the inside to be 2.5 inches. Now as you can see, the outsides here are a little off. They're not proportional. So what I can do is I can do a Smart Dimension on this side to set the distance between these gaps. So I can do 0.2 if I want, and that'll kind of move it. If I want it to be exact, I could delete the Smart Dimension. And what I can do, you can select two lines. So I'm going to draw lines to the edges. This is a chance that you might want to use the zoom in tool to really zoom in there. So now I can select these two lines. So as often you want to double click out to get back to your mouse. And then I want to make them equal. Oop. Alright, we have an issue. Because this is Smart Dimensioned,
Oh, yeah,
I want to delete the Smart Dimension. That's the only way to make them equal. Is everybody following along with this part? This part's a little trickier, but there we go. We got them equal now.
Yeah, is there anyone who needs us to pause?
How do you get rid of the Smart Dimension?
You can just click on it and then delete. Push backspace or delete. That's pretty.
How do you make
That's
the
about
two
it.
lines equal?
How to make the two lines equal? So if you go and you select the two lines. So if you ever need to go back, so right now I'm back to like the main screen, the main kind of project build. So if I click on Sketch 2, I can go up here to the top left and hit Edit Sketch, and now I'm back in the part that I was just working on. Whereas Boss Extrude 1, you can always go through and title these as well, was that initial base that we built. So if I click one line, it'll select it. This is how I make them equal, and then I hold Control, but you can also use Shift, I believe. You can select the other line, and then there's all these different options down here. So I just clicked equal. So if they were lines that needed to be parallel, I can make them parallel, perpendicular. You can fix 2 points to the same point. And then I double click to get out. I always use double click to kind of get my way, to kind of move back outward. So let's go and do the same thing quickly with the other sides. We're going to build 2 lines from these points, and we're going to make them equal. And once they are equal, you can kind of set the dimensions on either way. So as you can see, we use the smart dimension to build this line, but we could do it the opposite way. We could set the smart dimension on the width, or on the gap if we wanted. And it would make the 2 lines equal based on the one smart dimension. Oops. Okay, so now our box is equal all the way around. So now we're going to build the walls up. What we need to do to build the walls up is we need an enclosed surface. So we could build up right now the inside of the box, because that's considered enclosed by these 4 lines. But we want to build up the outside. So we need to actually draw new lines along the edge, since this is considered a separate sketch than the first one. So you can just use the corner points, and you can just do it in a couple clicks. Just draw to the corner points, each line. Every time you draw a line, if you noticed, it kind of picks up and draws and plans to draw the next line until you get back to a point. So there's our 4 lines around the outside. So now we have the outside of the edge of the wall and the inside edge of the wall. So next, we want to close out of that, and we want to go to our features again, and we want to do a boss extrude. Now this time there's multiple spots to choose. So last time there was only one thing that could be boss extruded, but as you can see, the red part is what's going to be boss extruded. So you can kind of select these different points, and it'll be set up to extrude what I selected there. There are different options to boss extrude. Usually we use blind. That's how you set just the distance and do it yourself. Sometimes you'll want to do up to surface. So if you want to connect, if you have like 2 planes and you want to connect something between them, you can do up to surface and select the surface, and it'll automatically boss extrude up to that surface. So right now we're just going to do blind, and we're going to make our birdhouse 3 inches tall. And then we check it, and we have rebuilding errors.
Might be because there's lines there too.
Yeah.
It doesn't make it full.
There we go.
Okay.
So make sure you select all the different points around the edge. Those little extra lines that I built to equal out the sizing kind of caused some issues in there. Alright, so there is the walls of our birdhouse. So if we double click, we're back to, do you have a question over there?
Yeah, how big is the extrude?
How big is the extrude? I set it at 3 inches. You can set it as tall as you'd like. So now we're just going to build the top, and we're going to do it the same way we just did the walls, except it'll be a little quicker and a little easier. So we're going to go back, we're back to the front. Is everybody back to the front? Double click out, and then we're going to select the sketch, draw another line. This time we're just going to use the rectangle, because that's easy, and we know that this is a rectangle. We're going to select the plane, which is the top face here. So you don't want to select down in here, you want to select this top plane. You can kind of see how it gets selected. So we're going to select that, then we're going to come from this corner and just drag our box down to this corner. Simple as that, and then we're just going to boss extrude that one. This time we only want it to be a 1/2 inch thick. Alright, so now we just have what looks like a box, but we know that it's hollow on the inside. So now we want to put a little hole in it for the bird to fit in. So we're going to pick the circle tool. Same way we've done the past sketches, but this time circle. We're going to select the face. You can select any face that you want. And the circle tool works, you build it from the center. So you select the center, and then you kind of build it out as far as you want. So I'm just gonna build it anywhere, and then I'm gonna set the dimensions of it in a sec. So there's my circle. I'm going to use Smart Dimension to pick the radius of the circle, or the diameter. So I want the diameter to be 1 inch. So there's my circle. Now you could use, you can use lines then to set up where your circle is the same way we set up the walls. So I'm just going to set 2 lines on either side and on the bottom. You see where I'm selecting the lines? The points come up so it's tangent, and then I can select it so that it's down. When something highlights orange, that means you're going to be tangent to it. So there I've selected my lines, or I've drawn my lines. I want to set these 2 to be equal, so that way it's centered. And then this one, I'm going to Smart Dimension, so that I know how far the circle is from the bottom. So I want it to be 1 inch. Now we're going to cut the circle out, so we're going to go back to our features. We're going to use Extruded Cut. We're going to select the circle. And this time, instead of using blind, I'm just going to go through all. Now if you notice, that will actually go through the other side, I believe. So if I do through all, we can check it, and we can see that it does go through all. So actually this would be a case where we would want to use up to surface on the other side. So to go back into it, we can click Cut Extrude, go to Edit Feature. I'm not going to use up to surface just because I can't see the inside of the box, but I know that the thickness of the wall is a certain amount. So if I set this to 1 inch, it should be enough to cut through. And it didn't go the right way. So this tool here, this little button here, it selects which way you're cutting. So if I click that way, obviously it's trying to cut out of the box, which wouldn't exist. So I want to cut into the box. So right there, I've cut into the box. And now we basically have our birdhouse. The last thing we're going to do, what you could do, is go through and add a little post, but to save time, we're not going to build a little post right about here. What I just want to show you guys is how to round off edges, which is pretty simple. You just use the fillet. So because what we've done is already built, we don't need to do a new sketch. We can just go to fillet, and we can select the edges that we want to fillet. And then we can select, this is the radius of what would be the fillet. So you'll kind of see it once I select it. We're just going to do this is in millimeters. We're going to do, I guess 10 millimeters is probably pretty good. And we're going to see how that looks. So there we go, we've rounded the edges. And you can kind of get a feel, if you want to go back and make them less round, you can change the radius. You can kind of get a vision of what it's going to look like. So anyway, that is a simple way to make a quick birdhouse. You could obviously keep building off this. You could sketch things, you could cut more things into it if you wanted to do some designs on the side. You could obviously build the post out, but I figured I would just give you guys a quick demo of how to put a couple pieces together. The cut extrude and the boss extrude are the main features that you're going to use when you're building things, and also the sketch tools. So that is your birdhouse demo.
All right. Thank you, Will. Thank
Thanks,
you. All right. So what I wanted to do is go a little bit through the transition from this to 3D printing. And we're going to do that, and hopefully if we have enough time, I just want to make sure we do. I actually have a tutorial that I'll show you here. And you can go through it on your own. And that's, I think, what Will said, by doing it, and instead of just, like, you've seen the basic idea of what you do with all the functions, but being able to sit there and have a list of of the steps to take will allow you to be more creative, allow you to go at your own pace, and that's what we want to do for you. So we'll do that after I do a little bit more on the background on transitioning to 3D printing.
Going back to the birdhouse, if anybody didn't finish it or wants to keep working on it, I'll stay around for a couple minutes and maybe show you something if you needed help.
Mm-hmm. Okay, so which one should we do first?
I can talk about the 3D printer.
Okay.
This one here. You can go ahead and start.
Oh. Oh yeah, so, oh, you meant to start this.
Yeah.
Okay, so we're just going to tell you a little bit more about the 3D printer, like how you work with it, how you're going to be able to work with it, and who you work through to do that. Because for the Makerbot, it is open to everyone, and it is free. So we can tell you about how to do that and go through that process. It's currently not working right now, so we also want to talk about the one that's in Sear. If you want to get serious about developing things, it does cost money, but the person who runs it, George Simmons, who's the person who actually bought it, said he's willing to discuss with people about if you have a purposeful reason to actually use it. So we'll go through a little bit more detail of what that entails. All right, so this is exactly what 3D printer does, especially the one, or specifically the one that we have. Do you want to talk more about this?
Sure. Basically, a 3D printer takes what we call resin, which is basically a plastic. There can be various forms. If you look at the one in the back over there, it's kind of in rods, whereas the one in Sear, it's a liquid in a jar or a compact container, basically. It uses a laser to heat up the resin, and then it kind of lays plastic layer by layer to build your material. So printers are rated in their accuracy based on how thin the layers are. The Makerbot, I believe, is maybe a couple millimeters, 1 to 10 millimeters of accuracy. So it's visible, you can kind of see the layers. Whereas the one in Sear, if you looked at that smooth one going around, you couldn't tell where the layers were. I believe they're 0.1 millimeters thick. So the 3D printer will layer plastic through the heated laser all the way up until it's built your project. It also uses a support material, the one in Sear. This one does not, but the one in Sear uses a support material. So if you want to build, let's say you're printing this birdhouse. If you want to build that top and you need that panel there, the printer would have to fill the entire birdhouse with support material so that it could layer on top, the top platform, which is kind of inefficient if you think about it, because the support material costs money and then you have to clean it out. So if you're building an enclosed structure, think about that and how you're going to get the support material out.
Yeah, actually I'm going to grab one of these just to give you an idea. So I was talking to George Simmons about this, and you see this specific part. It has 2 holes in the center here, and the way that he printed it was this direction. You can actually see, I'll pass this around again, where the support material was placed so that it could make this extrusion here. But what would go faster is if you actually printed it like this. But the thing is, in order to build on top of it, this would all have to be full of support material, all what's inside this hole. Since you print it this way, it's going to take probably 3 times longer, but that's a sacrifice you have to make when it's going to cost a lot less money, because you don't need support material here because there's nothing on top of it. So when you're creating your ideas that you can send to me, think about that in the support material and how you can be methodical when you're making something that you're going to 3D print. Like Will said, if we actually tried to do the birdhouse, it would have to fill the whole inside with support material, and that's almost just as expensive as the actual plastic itself. So, okay, this is actually the Villanova University's official presentation for the 3D printer, so this is just a little bit of background on how it came to be. We do have this particular Makerbot. We don't have the,
This one here.
yeah, that's the one that we have in the back. You can make all of those different things. and that's a different machine that we don't have here. Makerbot, a very huge, like they have disrupted the market with 3D printing because they make it easy to do in your home. So if you ever wanted to buy one, like this is something that you could actually buy for an affordable price. Okay, so this is the object that's inside SEER 105. It's a very expensive piece of machinery, so only certain people are allowed to work with it. I know Will has been trained, and George Simmons would be happy to help you with it. But just so you can see.
So these are the resins that you can use. Our printer only does 2 colors. It does cream and black. So the 4 containers there, it needs 4 containers, 1 for each color, and 1 for the support material. So you have white mono material, white support, black mono, black support. So that's where you load the material, and the one over in SEER is a liquid, so it kind of uses the liquid and heats it up to a solid. And then this is Object Studio. You're really at SEER, you do have to be trained to work Object Studio directly interfacing to the printer, but you're free to download Object Studio yourself. This is where once you save a part, you can load it into Object Studio, and this is where you can see how much it'll cost and how long it'll take to print. And this is the tray that you actually build. So this here is the tray, and this is where you line up the parts, and this is how on the printer it would come out like this. There's some different options up here when you're in this Object Studio where you can do a cost estimate, and it'll give you the amount of model material and the amount of support material that's going to create, and we'll give you figures on how much that costs. It's per gram, and it'll give you the per gram figure, and it'll also give you a time estimate. You can also use the tools up here to rearrange the pieces. There's an automatic placement that'll try and place it as optimal as possible, but sometimes you can get away from the automatic placement and lay things in different patterns so that it'll use less support material or less time.
So that's just an example of an assembly. These are all actually individual pieces, and in assembly, which is what Will was talking about, you mate them together where you make the face of one part mate to another, and they're connected and you can move them around as one. So that's just the tray layout. That's the actual tray.
So this is when it's completed. This is what it would look like. The printer lays a small layer of support material under each so that it kind of sticks, and then you have to scrape it off. Don't go and try this because George will be really upset. Make sure he trains you, or you have somebody trained to take these off for you. Basically, the support material is just a small layer on the bottom. You scrape it off the printer, and then you have to scrape the material off the bottom then.
Yeah, and another thing to think about when you get better at this and you do it more often, whatever the support material touches isn't glossy anymore, so it's going to be matte. So if you're doing some kind of design and it's face down, which is actually what happened to me this summer, it's not going to be glossy. So that's another limitation to the 3D printer. So this is some of the tools that you use to make sure that you can get all the support material off. You can buff it so it becomes glossy, but essentially you need to do as best as you can using all of these to go into the little crevices. There's a personal toothbrush you can use. There's a lot of scrapers. And then also alcohol is very helpful for getting that off. And then the most effective one is this fun contraption that's down in the SEER lab, where you can actually put it inside of this tub and water jet it with a...
It's basically like power washing. You just kind of power wash the pieces clean.
Yeah, and it's very, very effective.
That's the main way that you use to clean the support material.
Yeah, and it's kind of fun because it has its own, you can see it's got its own windshield wiper so that you can see what you're doing. And
you have to be careful too. It's so powerful that you can break your parts. So you got to make sure your parts are either sturdy enough. You'll find if you start 3D printing a lot that you can print things that are so thin that they are fragile. So you got to think about that when you're building as well.
Okay, so these are the pricing. This is the pricing, and this is very important to pay attention to, because this is exactly what you have to pay after you've completed your part. Usually, the engineering school does cover that, especially for our entrepreneurship projects. But for example, we had our competition, and we were trying to make money off of 3D printing, and so that we could donate it to an organization. but it was actually very hard to do that because it was so expensive. This is very much for prototyping, rapid prototyping, being creative, and getting the part done really fast. But in the end, we realized that if we had made our parts just with a mold and metal, it would have been a lot cheaper than actually doing it with 3D printing. So that's where the limit is, and that's what the use is going to be. So that can get your wheels turning too about, well, what else could we use 3D printing for, even though it is very expensive. So keep that in mind also.
To give you an idea of what this is, a lot of us can't think in maybe per gram terms. The birdhouse we built, I would estimate to be about $20 worth of monomaterial. Because it is so tall, we did a couple inches, and it was about 5 inches wide. And then the support material to fill the inside would probably end up being about another $20. So that's almost a $40 birdhouse. A lot of times you have to think in small terms if you want to do things, or flat terms. You can build a lot of things if they're pretty flat, and you just build a little bit of 3D up. But yeah, just something to keep in mind. The monomaterial does get expensive, and the support material as well if you're trying to fill a lot of gaps.
These are some of the examples, as Will was saying, that $84.50 piece. I forget what its purpose is, but basically they could make money if they sold one and sold it for $100, but that's something to think about. Actually, one of the most successful, they've hosted the competition multiple times. The one that was most successful is that shamrock right there, and that's because it was so cheap to make, and it was just a cute little thing that you could put on a keychain for the KD sorority. So that was one of the winners also. Okay. Oh yeah. Well, there's also, it's not just plastic that you can print in. There's an object actually that's even bigger than the one that we have, and you can make anything from metal to bendable plastics. So there's a lot of different types, and you can actually 3D print a gun. So I think, is there anything?
That's probably the only one.
Yeah, okay. That's all I wanted to show you from the actual one. And now we're gonna return to our prototype. Okay.
Yeah, you're good there.
Okay, so here's what I want to do for the last the 15 minutes. You guys can stay as long as you want. We're going to be here. Well, I'll be here too, and Will's willing to stay. But I'm going to have you go to this link, and it's going to get you to this tutorial. And I'm going to let you guys go through this on your own. And we'll be here to help you through it. And if you have any questions, raise your hand. You can get as creative as you want and what is going to be the end goal. This is a really good exercise for fillet use, shaping, making sure you get familiar with all the functions of smart dimension. And this will eventually get you to, there's a lot. You don't have to go all the way to the end. What I wanted you to get to is this, actually. That's the final design. And then if you want to go further with this afterwards, there's a lot more that you can do with this. And this is giving you an idea of how you can build this. And this would be a pretty cheap part also because of its design. So I'm going to have you guys go as far as you can with that, but we'll be here to help you out. If you want, I'm going to put this up. Do we want to talk more about the Makerbot Desktop then? Before we have them do this?
I'll just talk about the file types for a little bit.
Yeah, do that.
So there's two different main file types that you're going to use in SolidWorks. A regular part is always saved as a solid part file. I believe it's SLDPRT. And that's the file that you bring into SolidWorks. If you want to print it, it has to be saved as an STL file. And that's universal for most printers. The Makerbot uses STL as well as the object. So when you save as, you just save as an STL, and then you can't really edit that STL file. So if you want to make more edits, you'd have to go back into the solid part file, edit that, and then save a new STL file. So those are things to consider. Oftentimes, if you want to print something at SEER, you can send it to George or you can send it to me, and you can send it to us as a solid part or an STL because we can always build the STL file from the solid part file. But that's just something to consider. If you want to take this deeper, or if you want to use the Makerbot in there on your own, you'd have to download Makerbot Desktop, which is there.
Yeah. I'll send this to you guys if you guys give me your email. And then I'll also give you mine so that you can send me your creative designs. I'm just gonna give you a preview. Oh, this is the Love one I was just testing out. This is the Makerbot Desktop. It takes a little while to download, so you don't have to do it now, but the really great thing about this is it's linked to Thingiverse, which you can actually get on your phone. And it's basically, you can explore all different types of objects that have already been created, and you can share it with other people. You can create something and people can like it, comment on it. And if you're really into this, you can delve very deep into your creative side and see all the different things, get ideas from other people. And I've really enjoyed going through this. Otherwise, you can definitely get more familiar. As you can see, I uploaded the file in an STL file here, and you would eventually print it, but I haven't downloaded it to the SIM card that you'd end up putting into the Makerbot, but this is essentially the interface, and you can mess with it like this. There's a store too, so if you're interested in like buying anything or just seeing what you can actually sell, people might want to sell that, and then learn. So this is very helpful, a very helpful interface. Lastly, so I'll send this to you guys. This is the basic layout. Thingiverse, very important. And then lastly, we'll say compete to get your idea printed. So design whatever you want. You can have my email. I'm going to leave it up on the slide. So anything that's creative, original, economically efficient. So think about orientation, all that, how much support material you're going to use. And then I'm going to, as I said, choose 2 designs, 1 to 2 designs, depending on how many people email me. And I'm going to have them printed on the object, which is in Sear. So thank you so much. I'm gonna leave this up after you guys are able to copy the tutorial down, because I'll let you, whoever wants to stay for the next couple minutes, work on this.
And if you're curious as to how much something costs, you can always email me, and I can do a cost check for you if you don't get the Object Studio working yourself.
Mm-hmm.
Any questions?
Yeah, any questions?
Yeah.
When do I have to send you that file?
I'd say by the end of the week.
This week.
This week. But you gotta get really into it. That's what forces me usually to get really creative. I kind of just sit there for a long amount of hours and just do it.
Because I have an exam tomorrow.
Okay, well, no rush. If you want to send it to me, no matter what, I'm not going to be able to get it printed until next week anyway. So if you send it to me over the weekend, then...
Yeah, make it till the end of Sunday, I guess.
Yeah, end of Sunday is fine.
End of Sunday.
Okay. Yeah, I'll just let whoever wants to stay and work on this, copy that down, and then I'll leave my email up. And I'm going to go get a piece of paper for you guys to give me your emails.
Or you could just have them email you.
Or you just email me.
Yeah.
Well,